Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. For more details of our institution, you can visit our website www.sapienceeducation.com. Apart from this, you can also download our app so that you will get so many materials and all. The link of the app I have described in the description section. So today our topic where we confined is the concept of potential energy, the most confusing one. So what actually potential energy means? So basically potential energy has no specific definition. So wherever we say, we talk about the potential change in a potential energy, change in potential energy, change in potential energy, right? Change in potential energy, and is equal to negative of work done by conservative force. That is, if I will tell about potential energy, so if you see you source your potential energy, then change in potential energy can be written as negative of work done by conservative force. Okay, so this is the concept of a potential energy, right? You cannot say that any object has some potential. No, an object has no potential energy. We always talk about the system. For example, there is an earth and there is a mass, so these both are a system. Okay, and these both are a system. So when an object is moved or changed, so there is a change, work is done against the conservative force, and this work done, when work is done, so then the potential energy is being stored. So that is change in potential energy. Another example I will give you, that is a spring mass system. For example, there is a spring and there is a mass. Okay, and if I will apply a force here, so definitely this spring mass force will able to displace itself from here to here. So definitely this spring mass system, it is your system, it is a system. Okay, and there is a change in a potential energy. Earlier it has some potential energy like this ui. After a while there is a potential energy uf. So this change in a potential energy will be negative of conservative force. This potential energy, the concept of potential energy is applicable only in a conservative force. It is only applicable in conservative force. What type of conservative force? For example, gravitational force. Another is your elastic force. Third one, spring force. Understood? So why there is a change in a potential energy is equal to negative of work done? So let us consider. I will try to explain you by using some of the condition. Let us consider there is a ground. Okay, there is a ground, and at this ground there is a building having a two step. Okay, a building having a two step, right? So an object is kept at this height. And the same object has been taken and kept here. Same object. So both are same object. I am talking about same object. Okay, so let it the height of this object is h1 and the height of this object will be h2. So potential energy can be mg h2 here, and here we can write here mg h1. So while moving from this height to this height, we have to do work against the conservative force. Which type of conservative force I am talking about? See, for example, when you take this object at a height h2, so what happens? Gravitational force will work against its motion. Okay. So now let us consider a change in potential energy, that is del u, and this can be written as u final minus u initial. Okay. So u final means what? mg h2 minus u initial means what? mg h1. Okay. Now if I will take here common mg h2 minus h1. Okay. Now again if I will talk about work done by the conservative force, so how I will write? So work done by conservative force, that is gravitational force can be written as W is equal to force into dx. But here force is how much? Force is what? See, an object is being shifted from height h1 to h2. So gravitational force will act downward. So this is your gravitational force, that is mg. And this is the dot product. We know that what is the dx change in height, that is equal to h2 minus h1 into cos how much? The angle between the movement and the force. So let us consider movement is upward and force is downward. Force due to gravity is downward and motion, that is h2 minus h1, is in upward direction. So what is the angle between these two? This is your 180 degree. So can I write here cos 180 degree? So this will be finally minus mg h2 minus h1. So from here we can get this is your work done due to conservative force, right? So work done due to conservative force. So can we write minus wc is equal to mg h2 minus h1, and can we shift this to here? So here we are getting del u is equal to negative of work done by the conservative force. So this is very important derivation. So I hope you all have understood why we always try to define that the change in a potential energy is equal to negative of work done due to the conservative force. Actually, if literally if you want physical significance here, so whatever gravitational force is acting, or gravitational force is doing work, and whatever we are doing work on this object, so it is being stored in the form of potential energy. Okay. For example, here an object is having a mass m, and it is being displaced by for a distance of h2 minus h1. So work done, we have to work against the gravity, and that work has been stored is in the form of potential energy. Okay. So change in a potential energy is equal to work done by the conservative force. Very important. You should remember, every time you should remember work done by the conservative force only. We are talking about work done by conservative force only. I hope you all have understood this. Now let us consider one more definition of conservative force. If we talk about very small work done, if del u is very small, and del w by the conservative force is very small, small work done has been done, and there will all both are variable. If both are variable, or we can say work done is a variable, so how you will write this? So as we know that when we talk about a small thing, so we should keep writing here, del u is equal to negative of del w work done, or du is equal to negative of dwc. Okay. Now if I will talk about work done by the conservative force, so this will be force, conservative force into dx, if x is the displacement. So can we write here, can we write here can we write here integrate both the side, integrate both the side, integrate both the side. So by integrating both the side, what happens? We can integrate negative of work done, that is equal to dwc. Okay, and it is your uh, initial minus final. So that is equal to uf minus ui, and that is equal to negative of f dx, and displacement is from ixi to xf. So this is also one term. So many place you will get this type of concept of a potential energy, right? Concept of potential energy. So always try to write here in a change in a potential energy. In a physics, we always write change in potential energy, change in potential energy. Why don't we write only potential energy? You know, because if there is a no change, so no potential energy will be there. For example, this is the earth surface and there is a ball, so these both are a system. Okay, so when both are systems, so we have to make some distance apart, then only we will get a change in a potential energy. And when change in a potential energy is there, then only we can say that change energy in a potential energy is equal to negative of work done by the conservative force. So we don't tell only potential energy, we always tell change in a potential energy. I hope you all have understood this concept. Okay, now I will talk about spring. Now one important note point is there. I want you must write one note point. Note point: potential energy is invisible form of energy, invisible form of energy. It is imparted, it is imparted to system, to the system, to the system, which is stored in the form of potential energy. Example you can see here. Example you can see here. See the girls with a arrow. See stage back. When she stage back, what happens? See, when she stage back side, so she imparts energy, and that energy is being stored in the form of potential energy. And after a while, when she leaves, so this potential energy gets converted into kinetic energy. Okay, so I hope you all have understood now. Now I will talk about the potential energy in the spring. Okay, so how you will find potential energy in the spring? So our topic is potential energy in the spring. Let us consider an object is being connected with the spring. Okay, when this object will be displaced for x1 distance, how much distance? X1 distance. So this object will come here. So somehow this object's initial position is I. Okay, and again we, if we displace more, so what will happen? What will happen if we will displace more? So what will be happen? What will happen? So it will got stage, so at a distance of x2. So definitely at this both the point, definitely at this both the point, work is done. When we move from one point to another, so work is done, and this work done against the spring is being stored in the form of stored in the form of potential energy. So can we write here del u, that is change in potential energy, is equal to what? So here you can write here uf minus ui. Now, and uf minus ui can be written as what? Negative of work done by conservative force. So our motto is to find work done by the conservative force. Here you know that spring has a constant k, and as we have studied in the Newton's law of motion, if we stretch spring, so it is proportional to the displacement. So force by the spring can be written as minus kx. Okay, now if I will talk about work done, so work done will be integration of f dot dx from x initial to x final. Or if I will talk about 1.1 and 0.2, so here we can write here 0.2, 0.1, 0.2 x2 to x1. Okay, sorry, x1 to x2. Okay, so how I will write here, you should understand here how I can write here. So as we know that force is equal to negative of kx, so can we write here x1 to x2 is equal to minus kx dx. So k is the spring constant, so can we write here minus k x square by 2 by using integration rule, so x1 to x2. So can we write here minus k x2 whole square by 2 minus x1 whole square by 2. So finally we are getting work done by the spring force. Work done by the spring force is equal to minus k x2 whole square by 2 minus plus x1 whole square by 2. Now this is the work done by the conservative force of the spring. Okay, work done by the spring. So we have already talked that you should always write here. If I will talk about change in a potential energy, so can we write change in potential energy is equal to negative of work done by conservative force. So here how much we have work done due to conservative force? Minus k x2 whole square by 2 plus k, here I have left k, so here it should be k, so k x1 whole square by 2. Okay, so this is minus plus, so k x2 square by 2 minus k x1 whole square by 2. So this is a change in potential energy. I hope you all have understood this. Okay, and you can write here u2 minus u1 is equal to k kx2 whole square by 2 minus k x1 whole square by 2. So by using this concept we will able to do the numericals. I hope you have got the message of the concept of a physics, concept of a potential energy, right? So we all have discussed. I don't think there is a confusion concept of potential energy. Potential energy. Always remember, change in potential energy is equal to the negative of work done by conservative force. Don't ever leave this. Okay. Always try to write conservative force. So I have also proved that how it can be done, and by using this only, I have also done some derivation for the spring constant. I hope you all have understood well. Thank you, everyone.